Welcome back at C Square. In this lesson we'll talk about inscribed angle on the first part. And you notice I said here there are some things that we call intercept arc. What do I mean by that? This is what we call an inscribed angle, angle G. The vertex is right here and the circumference on the circle, and this is what we call the intercept arc. Arc HD. Very similar here, we have an interior angle J. This was G, and this is the intercept arc. Now you notice here the chord, one of the chords is the diameter JK. And the last picture we have another angle. Okay, and this is the intercept arc. So the inscribed angle is V and the intercept arc is NO. Now you have kind of all the possible choices for an inscribed angle. What is important about an inscribed angle? That this is what the theorem says. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercept arc. So let's take a look at what we have here. An inscribed angle P, the measure of that angle, it's 1/2 of the measure of the arc. You can see this in the other way, which is the measure of the arc, it's twice the measure of the angle. Sometimes that relationship is better, you can use it for solving problem. The next theorem you see here, it's two inscribed angle of a circle intercept the same arc or congruent arcs, then the angles are congruent. You can see that in this picture. For example, angle P has this intercept arc, but angle R has the same intercept arc. That's the reason we said these two angles are congruent. Of course, if you take a look, we have a very similar situation of angle N and M. They have the same intercept arc RP. Now let's take a look to some problem. And on this example, on part A, we need to find the measure of arc MN, which is this gentleman. And if you remember, what do we know? The measure of the arc, that's what we need to find out. It's twice the measure of the angle. So in this case, we have 2 times 42, and that will be 84 degrees. This is the measure of arc MN. 84 degrees. Let's take a look to part B, where we have to find the measure of angle P. And what do we notice here? This arc is given to us, it's 64 degrees, so we're gonna use the measure of angle P. The inscribed angle is 1/2 of the measure of arc MN, the intercept arc. So in this case we have 1/2 times 64, and that will be 32 degrees for the measure of angle P. 32 degrees. Let's move to the last one, which is probably the next level in this objective in this lesson about inscribed angle. So we need to find the measure of angle P. For that reason, we will need to find out how much this arc is, which we do not know, as you notice. So I'm gonna call it X, but I'm looking here, I have this arc, which is 134, and I have one more, this arc, which is 1/2 of the circle. So this will be 180 degrees. How do we know? We see this diameter here, and that tells us this is 1/2 of the circle. So I'm gonna write here X plus 134 plus 180. If we add these three arcs, we get 360. So we have here x plus, let's see how much is 134 plus 180. That is 314 equals 360. For finding x, I'm going to subtract 314 on both sides. So we have x equal 46. And remember, this x is the measure of this arc, 46 degrees. So what else we need to do to find the measure of angle P? We need to divide that by 2, because the measure of angle P, the inscribed angle, it's 1/2 of the measure of arc MN. So that will be, I'm going to move here, measure of angle P will be 46. Divide by 2. So the measure of angle P is 23 degrees. Okay, and that is the first example in this lesson. And the second example, we're going to use the second theorem I mentioned a couple of minutes ago, which tells us that, for example, angle P here and angle R are congruent. So here I should say find the measure of angle R. The measure of angle R is the same of the measure of angle P, because these two angles are inscribed angle and they have the same intercept arc. So the measure of angle R will be 68 degrees. Okay, on part B, very similar. We look into this problem, and what do we know about angle P and angle R? They are congruent. Why? They are inscribed angle, and guess what? They have the same intercept arc. So that's the reason these two angles are congruent. Angle P congruent to angle R, which means the measure of angle P equals the measure of angle R, which means the algebra is 5x plus 12 equals 7x. I will personally subtract 5x here to eliminate this positive 5x. Don't forget to do the same thing on the other side. So we have here 12 equals to x. And the last step to find x is divide by 2. So x will be 6. Now we need to find the measure of the angle. So I'm going to go angle P. And that will be 5x. 5 times 6 plus 12. That will be 30 plus 12. That will be 42 degrees. This is how much the measure of angle P is. And how much is going to be the measure of angle R? The same. Remember, these two angles are congruent because they are inscribed angle and they have the same intercept arc. On my next part of the lesson, we're going to talk about inscribed polygon, and we're going to start with what we call inscribed triangle. And you see in this picture we have 3 inscribed triangles. On the first picture here we have an acute triangle, obtuse, and this one, take a look, is a right triangle. Okay, by the way, you can notice for the right triangle the hypotenuse is the diameter of the circumscribed circle, right? So remember these two terms: inscribed, that means inside; circumscribed, that means around. And let's see some example here. Find the value of x, y, and z in this case. Okay, so let's start with x, and I want to be sure there is more than one way to do this problem. X is the measure of this arc, and for that reason we're going to need to find out how much this angle is. And if you take a look, we have that triangle MNT. Okay, and in that triangle, what can we say? We can say the measure of angle M plus the measure of angle N plus the measure of angle T, the one I want to find out, is 180 because it's a triangle. So we have 37 plus 65 plus the measure of angle T equals 180. We're going to have to add 37 and 65, and that will be 102. And the last step, subtract 102, and we have the measure of angle T is 78 degrees. So if this angle is 78, how much is this x? And that x, you need to double it. So let me put that here. X will be twice times 78, and that will be 156. That is how much that arc is. Now let's take a look to the next thing, which is y, which is this arc. And what do we notice here? For this arc we have this, for this intercept arc we have this angle here, this inscribed angle. Y will be nothing else than twice that measure. Remember, the arc is twice the measure of the inscribed angle, and that will be 74. So this guy here will be 74 degrees. Okay, and now we need to find z, and for z we have choices. Like I said, it's more than one choice. But I think the easiest one is to look what this z is. This is the arc for which the inscribed angle is 65. So z will be 2 times 65, and that will be 130 degrees. And last thing you can do to check, add this number 130, 74, 156. You should get 360 because that is the whole circle. Let's take a look to part B now. Part B very similar, but we should notice something very important. This is a right angle. So can I just go and say z is 180? Yeah, because z is twice the measure of that inscribed angle, which is 90 degrees. So that will be 180. What about y or x? You see, I start with z. Okay. What about y or x? So I think the easiest way, maybe it might be a different way, is to look to this 68, which is this arc. Okay, so the measure of that arc is 68. That allows me to find very fast the measure of angle C. The measure of angle C will be half of the measure of arc AB, because that is an inscribed angle, right? So it's going to be 1/2 times 68, and that will be 34 degrees. That is the measure of angle C. So why did I need that angle C? Because now I can find x here, because these two angles, angle C and angle B, are complementary. They are acute angle in a right triangle. That's what I said here. They are complementary, so we're going to have x plus 34 equals 90, and for finding x we're going to subtract 34, and we have 90 minus 34, and that will be 56. So we have x, which was the measure of angle B, this one it's 56. Now how do we find y? Let's take a look a little bit. This is y, which is this arc AC, which is the intercept arc for angle B. So basically I'm gonna say here the measure of arc AC, it's twice the measure of angle B. So that will be 2 times 56, because angle B, remember, its x is 56, and that will be 112 degrees. And that will be nothing else than y. And that's it for this example. On the very next example, you notice we have only expression, so that will be a little bit interesting. But however, let's take a look what this expression represents. Let's say this one, the first one, x plus 52 is this arc. Let me write it here. Then 8x minus 16 is the second arc, this one. And the last one is this arc. So if we put these three arcs together, if we add them, what do we get here? We get the whole circle. I'm sorry, the whole circle is not 180, it's 360, right? Okay, so now we have to find x here, so we're gonna combine the things that are alike, and we have here 9x, 14x. And then we have 52 minus 16 plus 35. That will be 71, so combine the like terms. That is 71 equals 360. I'm gonna subtract 71 on both sides. And we have 14x equal 289. And the last step, divide by 14. Not so sure if we get a nice answer, maybe not. I don't think so. Yeah, we get something that is not really a fun answer. I will leave it like that, 289 over 14. But now let's take a look, because the problem really does not ask us to find x. It does ask us to find the measure of arc AB. And if you take a look, arc AB is this gentleman here. So the measure of arc AB is 8x minus 16. So it's going to be 8 times x, which is 289 over 14 minus 16. I'm not so sure if this is going to be a nice answer, but we can try to see what's going on here. Okay, so so I'm gonna do that. 8 times 289 divide by 14, and it's not nice, minus 16, but I think we can live with that. And the measure of arc AB will be, I have here around 149 degrees. Okay, so like I said, the nice answer is not nice. I'm gonna put here an approximation just to be sure. It's not exactly 149, but let's work with this 149. And now on the second part, let's identify the type of the triangle. So now if this arc is 149, we can find this angle C just by dividing by 2, right? let me do this here. Measure of angle C will be the measure half of the measure of arc AB. So that will be that 149, that approximation, divided by 2. So the measure of angle C will be, let's do an approximation also here. 149 divided by 2, and it's 74.5. Okay, well, we have to do the same thing. We need to find the measure of angle A and measure of angle B, and for that reason I'm gonna find first the measure of arc AC. Okay, and that is 5x plus 35, 5 times that interesting answer I have, and let's see how much that is. 5 times 289 divided by 14, that will not be nice also, plus 35. This was plus 35. And again, I'm gonna work with an approximation that the measure of this arc is approximated 138. Okay, so this arc is 138. Now I can get the measure of angle B. The measure of angle B will be what? 1/2 of the measure of its intercept arc, AC. So it's going to be this 138 divided by 2. So the measure of angle B will be an approximation, again 69-ish. Okay, now the question is, how do I find the last angle, angle A? So remember, that is a triangle, so measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And I'm going to use these approximations. Measure of angle A is the one we're going to find out. B is 69. And C is that approximation, 74.5 equals 180. Okay, so let's add this 69 and 74.5. That will be 143.5. And the last step, subtract that 143, and that will give us the angle A, and that will be 36.5. So now looking to these three angles, we notice 36.5 I said, they are not equal. None of them are equal. So this is an acute triangle, scalene. It is not a special triangle, right? I'll say acute because all the angles are acute. And scalene, nothing is equal there, right? No isosceles, nothing else, no equilateral, no right triangle. My next problem will have this inscribed triangle, but I want you to take a look to this inscribed triangle, because it says here AC is the diameter. It says, and also we can see this is the center of the circle D, so that is the diameter. That means this angle here should be 90 degrees, because this arc here is 180, right? And we need to find the value of x. So now, since we know this is a right triangle, let me write here, triangle ABC is a right triangle. And of course, it will be very important to know the justification. And like I said, this triangle is inscribed in a semicircle. Okay, then we can say the measure of angle A plus the measure of angle B equals 90 degrees. The acute angles in a right triangle are supplementary. So naturally my equation will be 3x minus 26 plus 2x plus 6 equal 90. So we have here 5x minus 20 equals 90. I'm going to add 20, so I'm going to have 5x equals 110, and I'm going to divide by 5. Last step to find x, and that will be 22 degree. All right. So that is how much x is. And we did find the value of x and find the measure of arc AB. Okay, the measure of arc AB. That's the second thing. So we have x here. Measure of arc AB is 3x, 3 times 20. I'm sorry, that's not correct. For finding the measure of arc AB, we need to know the angle C. We need to know this angle because arc AB is the intercept arc for angle C. So the measure of angle C is 2 times 22 plus 6. That will be 44 plus 6, and that will be 50 degrees. And now if we know the measure of angle C, what do we need to do to find the measure of arc AB? We need to double this guy. Remember, if we know the angle, you double it and you get the arc. So the measure of arc AB will be 2 times 50, and that will be 100 degrees. And that was the second part in this interesting problem. And then we need to identify the type of triangle. Oh, I already said this is a right triangle. Is another type of triangle? No, really, because angle C it's 50 degree. That means this is a 40. I was looking, maybe it was an isosceles right triangle, but that's not the case. So yeah, we did that. Triangle ABC, it's a right triangle. That's the last part in this problem. My last part of the lesson will be still about inscribed polygons, but now we're going to move to the quadrilateral. So like I said, you can inscribe any triangle. However, for quadrilateral, not all quadrilateral can be inscribed, just some of them. And what is important about inscribed quadrilateral? Look at here. The measure of angle A plus the measure of angle C, I said right there, is 180. Opposite angle are supplementary. And here I should say measure of angle B plus the measure of angle D. Okay, these two angles also are supplementary. Okay, they are not congruent, necessarily congruent, but they are supplementary. Opposite angles are supplementary if a quadrilateral is inscribed in a circle. That's what the theorem says. So let's see how we use that. Then we have this example here. And how do we find this x? Look into this picture, we notice is an inscribed quadrilateral. So the measure of angle A plus the measure of angle C equals 180. Those are opposite angles. So we have 123 plus x equals 180. I'm going to subtract 123, right? And what do we get there? 180 minus 123. Is 57. And let's move to find y. Okay, very similar, right? Y goes with this 85. I'm going to write again the geometry stay, measure of angle D plus the measure of angle B equals 180. The opposite angles in an inscribed quadrilateral are supplementary. So we're going to have y plus 85 equals 180. Subtract 85 and we have 95 degrees or 95. Okay, a very simple and straightforward problem, but the next example is nothing else than very similar, only we have expression. So what will be here? The geometry is the measure of angle A plus the measure of angle C is 180 degree, right? These two angles A and C are supplementary. Why? Because this is an inscribed quadrilateral and the opposite angles are supplementary. So we have 44 plus 3x plus 1 equals 180. We're going to combine these two. That is 45 plus 3x equals 180. We're going to subtract 45 on each side. So we have 180 minus 45. That will be 135. And the last step, divide by 3. So we have this x now, 135 divided by 3 is 45. And we can move to find y. Okay, so for finding y, very similar, we're gonna look to these two gentlemen, right? And let me write again the statement, the geometry statement. I think it's important. Measure of angle B plus the measure of angle D equals 180. And we have 110 plus 2y plus 10 equals 180. And that will be 2y plus 120, right? Because we combine these two guys is 180. Subtract 120 on each side, so we have 60. And the last step, divide by 2, and we have y equals 30. So one more time, the opposite angle in an inscribed quadrilateral are supplementary. And my last problem in this lesson is this one. Very similar to the other one, the only difference, kind of a scary thing, because we have this 2x plus 3y here. But let's start with the first thing. The first thing I'm going to do, I'm going to find x, and I'm going to look to these two angles, which are supplementary. If you said that, that's great, because that's how they are. And now I'm going to write the algebraic statement. 83 plus 5x plus 11 equals 180. So we have here 5x plus 83 plus 11, it's 94 equals 180. And we're gonna subtract 94 on each side. So we have 180 minus 94. That will be 86, and we end up with something that is not nice. Like in a previous problem, I apologize for that, but sometimes that's the case. And here is not going to be that bad like the previous one. It's going to be 17.2. Okay, good. But now, how do I find y? For y, I can go and write something very similar. If you remember, I'm gonna say this angle plus this angle equals 180. The measure of angle D plus the measure of angle B equals 180 degrees. They are supplementary because they are opposite angle in an inscribed quadrilateral. So we have 2x plus 3y, right? That is the expression for angle D, plus 120 equals 180. So now remember, we have x. X is right here, so we're going to have here 2 times 17.2 plus 3y plus 120 equals 180. 2 times 17.2, that is 34.4. Let me double check. Yeah, that is correct. Plus 3y plus 120 equals 180. Let me erase a little bit here. This is the number 4. So now we can add these two. They are alike. 34.4 plus 120. That will be 154.4 plus 3y equals 180. We're gonna subtract this 154 on both sides. So 180 minus 154.4. And that will be 25.6. And then we're gonna divide by 3. That's the last step. And that will be 8.5. I'll keep it like that. I'll round it. Let me put here the sign that we approximate, just to be sure. Okay, I apologize for this unfriendly answer. Yeah, sometimes that's the case. Okay, and that's it for today's lesson. I hope you enjoyed this lesson. If you enjoyed, don't forget to click the like button. Come back on C-Square for more help. Thank you.